I'm sure you won't mind, but during the break, I went ahead and took the route map off and took the access list off. You can see how I did that right in the middle, just with no route map next hop and no access list 5. Then went on the Ethernet interface on router 1 and took that policy off. So just putting the word no in front of each of the original commands took care of that business. Let's go back to the diagram and take a look at the more detailed policy routing. Whoops, excuse me. The more detailed policy routing we want to do this time around. We want traffic to be policy routed on router 1 and have the traffic have the next hop 172.12.123.3 if traffic is sourced from 31.1.5, which is router 5's Ethernet interface, and it's destined for router 4's loopback at 4444. We want all other traffic from router 5 to take its natural path. So the silliness we saw there at the end of the previous video with the traffic going from 5 to 1 to 3, back to 1, and then over to 2, we want to avoid that. If router 5 sends packets to router 2 at the end of this lab, we want them to go straight from 5 to 1 to 2. But if traffic's going to the loopback, we want it to go through router 3. We can do that with policy routing. Let's go ahead and bring our rack back up. And the first thing we need, the big difference that we need here is, of course, an extended ACL, because a standard ACL only gives us the match on the source. So let's go with access list 105, permit IP host. Of course, first we're listing the source, which is 31.1.5. And then we need to put another host, 4444, and that's it. That ACL line matches traffic sourced from 31.1.5 and destined for 4444, as long as we apply it correctly, which is exactly what we're going to do right now. Next hop permit 10, match IP address 105, and we're going to do a set IP next hop again for 172.12.123.3. And that's it, because traffic now that does not match ACL line 105 or ACL 105, which is one line, pardon me, traffic that does not match that is going to be normally routed. If I wanted to get rid of traffic that doesn't match it, I'd have to put another route map clause in and do a set IP next hop null 0. I'd have to send it to the null 0 interface. So since we don't want to do that, let's go back to interface fast0/0 IP policy route map next hop. All of this should look incredibly familiar. And hopefully that does it. Let's go over to router 5 and send a couple of trace routes. First, we'll make sure we can still ping. And notice these pings took about the same time. This time the round trips are 64, 65, 68 milliseconds. So that kind of tells me right there traffic going to 123.2 is going directly there. But of course hunches don't matter. We still have to prove it. Still got to show your work. Trace route 4444, you can see that it goes from 31.1.1 to 172.12.123.3 and then finally to 234.4 like you would expect it to. Now let's do a trace route on 172.12.123.2. And you can see this time, instead of the 4 hops we saw in the last video going to this address, now it's just 2. So the traffic is going exactly where it should go, and it's going directly there. The only traffic that's going to be policy routed, again, is traffic leaving 31.1.5 and destined for 4444. And that's it. That takes care of policy routing, but there's that word again. What if we needed to do some policy routing on packets that we originate on router 1? We're going to do that at the beginning of the very next video, and I will see you there.